Welcome to myprojectbazaar.com. Now we are going to discuss about the product medical image forgery detection for smart healthcare. Now we are going to discuss about the abstract for the process. This process presents a new unsupervised distribution free change detection method for the medical images based on the SIFT keypoints and then the region information. SIFT is represented as a scale-invariant feature transform. Since the SIFT can detect the blob-like structures in the images and be intensive or to noise, we first extract the noise robust SIFT keypoints in the log ratio image to reduce the distortions range. Then, in order to obtain the accurate change regions rather than the directly obtain the change detection map from the different image, as in some traditional changes detection methods like the background subtraction, we can segment the around the extraction keypoints in the two original multi-temporal SAR images or in the medical images where the edges of detection regions are much clearer than those in the difference image, and further compare the two segmented to generate the change detection map. Hence, this process is based on the feature extraction segmentation basis. In the feature extraction, by using this SIFT keypoint extraction, we extract the exact regions in the image, and then for the segmentation, here we apply the segmentation to reduce the background subtractions and then extract the foregrounds. Then the exact tampered regions will be extracted. Now we are going to discuss about the flow diagram for the process. At first, the input image is taken from the dataset. The dataset consists of the several tampered image. After getting any one tampered image from the dataset, the over segmentation is carried out. In this over segmentation, the SLIC segmentation method is used to over segmentation. Over segmentation is otherwise known as the approximate segmentation of the region. Then the block separation is carried out, and then the block feature matching is carried out. In the block separation, we just identifying the local key points from the image by using the SIFT feature extraction method. After the extracting the SIFT feature extraction, the block feature matching is done based on the distance calculation. Hence, the feature extracted from the image will be matched by using the block feature methodology. After these two steps, the local feature identification and then the local feature matching will be carried out. In this local feature identification, the image will be converted into an binary image. For example, the foreground regions will be the ones regions, that is the white regions, and then the other backgrounds will be eliminated as an zeros regions, that is the black regions. This is the local feature identification. After the local feature identification, the local feature matching will be carried out to reduce the unwanted regions present in the segmented image. After neglecting the unwanted regions, the corresponding ROI, that is the region of interest, will be extracted from the image. That region of interest will be the tampered region. After these steps, the foreground region identification will be performed. In this step, the foreground region, that is the tampered regions, will be shown and then the other regions will be eliminated. At last, the performance measures will be carried out by the parameters like the precision, recall and F measures. By these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2015b and change the current directory. Now you want to execute the file means main, just right click in the main_GUI.yum and select the option run. Now the initial GUI window was open. In that you can see the several axes and then the table for the display purpose. First of all, click the file to import image. After clicking this file to import image, you can see the several dataset images, medical images which consist of the tampered region. Select any one image from the dataset. After the selection of the input image from the dataset, the corresponding image will be shown in the axis 1 with the title input image. After the input, the pre-processing will be carried out. In this pre-processing, the image resize will be carried out, and then the corresponding image will be shown in the axis 2 with the title resized image. After the resized, the feature extraction will be carried out. In this feature extraction, the feature points will be extracted by the means of the SIFT feature extraction, as well as the over segmentation is done by using the SLIC algorithm. The SLIC image will be shown in the axis 3 with the title SLIC image, and then the SIFT feature extracted image will be shown in the axis 4 with the title SIFT features. After the feature extraction, the featured image will be like this. Then the segmentation will be carried out by the two stages. First one is the merged region, then second one is the final identified image. After clicking the segmentation, it will take some time to execute for the comparing the original image with the ground truth image. Now the results will be displayed like this. First one is the labeled feature points. Labeled feature points will compare the tampered image with the ground truth image. Then the image is converted into a binary form. After the initial labeling, the merged regions will display the exact tampered image in the binary format. After that, the detections will be like this. The detected foreground regions, this is also the detected foreground regions. Hence the results will be like this. After getting the tampered regions, the performance will be evaluated by the precision, recall and F measures. Those values will be plotted in the graph as well as the table format. Thanks for watching this video.